Good evening all, am I audible? Good evening everyone, am I audible? Good evening all, am I audible? If am I audible, then just type S in the chat box please. Yeah. Thank you all for your response. Okay. For the past last few days, you have assigned for 2 assignments, right? So I have told so many times, don't forget to copy that link and paste it in the Google form. But still, some of you just type LinkedIn, Facebook in the link tab instead of. So shall we start? So today, like your communication, I2C only uses 2 wires to transmit data between devices. One is data line and another one is clock line. So SDA, serial data. This line for the master and slave to send and receive data. And SCL, which is serial clock, that line carries the clock signal. So I2C is a serial communication protocol. So data is transferred bit by bit along a single wire. So like SPI, I2C is also synchronous. So the output of bits is synchronized to the sampling of bits by a clock signal which is shared between master and slave. So this is synchronous because I2Cs also need clock signal. So the master here also, the master always control the clock signal. So now let's see how actually I2C works. So with I2C, data is transferred in messages. So in UART you can see like packet, right, packet. Right. So here it is message. So these messages are broken up into frame, address frame, data frame and data frame 2 and stop condition, start condition along with this too. So each message has an address frame that contains the binary address of the slave and 1 or more data frames that contain the data being transmitted. So the message also includes start and stop conditions, read-write bits and acknowledgement and non-acknowledgement bit between each data frame. So let's see one by one what it is. First, start condition. So the data line switches a high voltage level to a low voltage level before the clock line switches from high to low to start the communication, which means to start transmission. And likely in stop condition, the data line switches from low to high after the clock line switches from low to high. And then coming to address frame, a 7 or 10 bit sequence unique to each slave that identifies the slave when the master wants to talk to it. So the I2C does not have slave select lines like SPI. So it needs another way to let the slave know that data is being sent to it or not to another slave, right? So it does this by addressing. So the address frame is always the first frame after the start bit in a new message. In SPI you can get to know whether the data is being transferred or not. In UART also you get to know. But what are the things? How do you know? It does nothing. The data line is still remains high. And coming to read write bit. So a single bit specifying whether the master is sending data to the slave or requesting data from it. So if it is low voltage, in the sense the master is sending data to the slave. If it is in high voltage, in the sense it is requesting data from it. So the address frames includes a single bit at the end that informs the slave whether the master wants to write data to it or receive data from it. So if the master wants to send data to the slave, the read write bit is a low voltage level. Data from the slave, then the bit is in a high voltage level. Then coming to acknowledgement and non-acknowledgement bit, each frame in a message is followed by an acknowledgement, no acknowledgement bit. If an address frame or data frame was successfully received, an acknowledgement bit is written to the sender from the receiving device. Then only get to know whatever I am sending is receiving successfully or not. And then coming to data frame, after master detects the acknowledgement bit from the slave, the first data frame is ready to be sent. So the data frame is always 8 bit long and sent with the most significant bit first. So each data frame is immediately followed by an acknowledgement or no acknowledgement bit to verify that the frame has been received successfully. So the acknowledgement bit must be received by either the master or the slave, just depending on who is sending the data, before the next data frame can be sent. So after all of the data frames have been sent, the master can send a stop condition to the slave to halt the transmission switch, to stop the transmission. So the stop condition is the voltage transition from low to high on the serial data line, after a low to high transition on the serial clock line, with the clock line remaining high. Now let's see one by one each step, how actually the I2C transfer the data. I am just explaining the message. Now we will see how it actually transfer the data one by one. 1 minute. Yeah. Is it clear? Is it clear, everyone? Now do you know what is I2C? If it is clear in the sense, just type yes in the chat box please. Let's move to the next topic, which is steps of I2C data transmission. Is it clear, everyone? Shall I move to this slide? Please be active in the chat box. If it is clear, then text X in the chat box please. Payush Sharma, thank you for your response. CSC Rohit, thank you for your response. Okay, so now let's see how it actually send the data to slave. So first one is this. So here is our master and here is our slave. So the master sends, first what is sent? The master sends the start condition to every connected slave by switching the data line. Here you can see data line. First it's switching the data line, then only it's switching the serial clock line. You can see the delay here, right? So it switches the data line from a high voltage to low voltage level before switching the serial clock line from high to low. Sending high to low signal to every slave. Slave 1, slave 2, slave 3. This is the first step. What is the second step? Now the master sends each slave 7 or 10 bit address of the slave it wants to communicate with, along with read and write bit at the end. So this is the read and write bit. So if it is in low in the sense it wants to sense the data, if it is high in the sense it acknowledges that it wants to receive some data from the slave. So it sends 7 or 10 bit sequence address to the slave. So the first slave doesn't match with the address, and the second slave also doesn't match with the address which is sent by the master. So third slave recognizes that the master's which address the master sent was matched with slave 3 address. So then third step is each slave compare the address sent from the master to its own address. If the address matches in the sense, the slave returns an acknowledgement bit by pulling the serial data line low for 1 bit. Here it is. These two addresses doesn't match, so the data line still remains high. This is matched with the master's address, so it sends a low signal for 1 bit. So if the address from the master does not match the slave's own address, the slave leaves the data line high like this. So the next step is, now the master sends or receives the data frame. This is the fourth step. And fifth step is, after each data frame has been transferred, the receiving device returns a acknowledgement bit to the sender to acknowledge the successful receipt of the frame. I have successfully received your data. For that it sends a low voltage signal acknowledgement bit to the sender. So sixth step is to stop, we have to stop the data transmission, right? So to stop the data transmission, the master sends a stop condition to the slave by switching the serial clock line before switching serial data high. So here you can see the delay difference here. First it switches the clock line, then only it switches the data line. This is how actually it works. Now, single master with multiple slaves, multiple masters with multiple slaves. So first this one. Because I2C uses addressing, right? So multiple slaves can be controlled from a single master with a 7-bit address, unique address or available. If the slave is free or some other master is receiving or sending the data or not. So to connect multiple masters, multiple advantages and disadvantages of I2C. First let's see the advantages. What are the advantages? It only uses 2 wires. One is serial data and another one is serial clock. And it supports multi-masters and multiple slaves, unlike SPI. And here it has the acknowledgement and no acknowledgement bit, which gives confirmation that each frame is transferred. Your address frame is transferred successfully. Your data frame is transferred successfully. You get to know. It will return you back the acknowledgement. So here, hardware is less complicated than UART. And it is well known and widely used protocol, I2C. And the other side, if you are coming to the disadvantages, compared to SPI, it is a bit slow data transfer. The data is transferred in a slow manner if you compare to SPI. Because SPI there is a MOSI and MISO line, so you can send the data and receive the data at the same time. But in I2C you can't do that, right? So you have to wait for the acknowledgement, and again you can send the data, and again you want to send the another data back, and then you have to wait for the acknowledgement. So it takes some time. So the size of the data frame is limited here. So in UART and I2C the data frame is limited, but in SPI there is no need for the data limit. You can send any number of data. And this is more complicated hardware needed to implement than SPI. Compared to SPI, it needs more complicated hardware. So this is all about the advantages and disadvantages of I2C. So now we have to see the main component which we are going to use in this session, which is PCF8574 I2C LCD. So this is our I2C. We are going to connect this with our LCD. So coming to LCD, there are many display devices like OLED display, 128 x 64 graphical display, Nokia 5010 display, etc. I think you are very popular with these names, right? So but for displaying simple text and number, all we need is a 16 x 2 or 20 x 4 character display, right? This is pretty much enough to just show it simple text or number. I am talking about, wait, I will show you 16 x 2 LCD. I think you already know that. For your reference, I am showing this image. This is a 16 x 2 LCD. So this is 16 x 2 LCD. So now get back to the topic. Okay. So the main disadvantage of this 16 x 2 LCD display is it requires at least 6 GPIO pins for a microcontroller to function properly, right? You have to connect all the pins from power pin, enable pin. There are so many pins in 16 x 2 LCD. You have to connect all the pins. You need a number of jumper wires to connect with the microcontroller. If you look like the LCD with the microcontroller, it will look like a clumsy. So this is not even the 8-bit mode, but reduced to 4-bit mode. Add another 4 GPIO pin. I am talking about just 4-bit. If you are taking 8-bit in the sense, it requires more jumper wires. So using that many pins of a microcontroller just for a simple character LCD display is not desirable, right? So especially if you are designing a project with lot of sensors and devices connected to the microcontroller, you need a lot of wires and it will look like clumsy. So for that purpose, we are using this module PCF8574 I2C LCD. It only requires 4 wires, which is ground, VCC, data line and clock line. Don't forget that you should power up with this 5 volt. You should give 5 volt power supply to this. So this module is designed to overcome this drawback. Instead of using many wires and many connections, you can just use this I2C LCD with 4 wires. Is it easy, right? So the name suggests the PCF8574 LCD module is a IC based module. So designed to convert regular 16 x 2 or 20 x 4 character LCD displays into I2C based devices. So which means instead of using 8-bit or 4-bit parallel interface to send data, you can use I2C bus to send data to the display. So this I2C LCD module includes the port to adjust the contrast of the LCD and pull-up resistor for data and clock line. So you don't need any additional connections. You can simply connect these 4 wires with your microcontroller and you can do program. So just plug in the I2C LCD module at the back of the 16 x 2 LCD and make connections between the microcontroller and the I2C LCD module. That's it. So for example, I will show you the connection here. Wait. Yeah. So this is easy. Here is our microcontroller. I only need 4 wire. This is our 16 x 2 LCD. At the back side, you will get your I2C. So it will soldering with this I2C LCD. How simple is this, right? So it only need 4 wires. So if you are interfacing the 16 x 2 LCD without I2C, in the sense I need to wire these all pins. Okay. Now let's see the ESP8266 I2C LCD interface. So the first thing we need to figure out, ESP8266 I2C LCD interface to work is the I2C pins of ESP8266. So if you remember, in the ESP8266 pin out part, I mentioned that the ESP8266 microcontroller has two I2C interfaces, right? Serial clock and serial data. Here is our I2C pins. So here we will be using GPIO 5, which is D1, and GPIO 4, which is D2. D1 is for serial clock line and D2 is for serial data line. So another important point to note is that the 16 x 2 LCD run on a standard voltage, which is 4.7 to 5.3 volts. So don't forget to power up your I2C LCD with 5 volt. You should give 5 volt. Don't give 3.3. So we cannot apply 3.3 as VCC to this module, even though the IC works at this voltage. So keeping this in mind when you are doing projects or when you are interfacing this with some microcontroller lessons, don't forget to give 5 volt power supply. Don't give 3.3 volt. So this is all about the theory part. Now let's move to the coding part. So first, before getting into the coding part, what you have to do is that you have to install one library to access this I2C LCD, which is Liquid Crystal I2C. So Liquid Crystal .h library here, I2C.h. So here you will get your library. Just go to this and you can download any one. So just click download, and after downloading it, you have to go to your Arduino IDE, here sketch, include library, add zip library, and go to where you have downloaded. So go to downloads and the last will be shown here, right? So just clicking open this, your library will install in this page. So another important thing is that next what we have to do is we need to find out. I already told you that every I2C LCD hold its unique address, slave address, right? So here also we need to find out the slave address of I2C LCD module. Since we are working with I2C interface, the slave address is one of the important thing we need to be aware of. So here ESP8266 microcontroller is the master and the I2C LCD module is the slave. So to find the address, you can just go to Google and search for code like how to find slave address of this module. You have to type that module name and I2C LCD in ESP8266. You can either copy that code and paste it in your Arduino IDE. After opening your serial monitor, you will get your slave address in the serial monitor. Otherwise, you can do one easy step. What you have to do is that after installing the library, you can get all of the example programs of that particular name. So go to files. You can find your slave address using that method also. Another easiest method is go to file, examples. Here you will get here it is, right? So Liquid Crystal I2C. Here it will show like 3 example programs: custom character, hello world, serial display. Click any one of this. So if you open any one of this program, here it already have your, but for that you have to connect your hardware with PC. First make connections and connect it to your PC. After that check this all. So here you will get your, so this line. So here you will get your slave address, and here it will show like 20 x 4, but it's not 20 x 4 LCD. Here we are using 16 x 2, 16 columns and 2 rows LCD. Your slave address is 0 x 27. If you are using I2C LCD, in the sense we have to mention these line in every code. Liquid Crystal I2C that LCD we create an object and inside as a parameter we have to pass its address, we have to pass its column, we have to pass its rows and all. So this is how you can find your address LCD in the easiest way. Is it clear everyone? Is it clear everyone? Shall we write the code now? Okay. So first what we are going to do is that we are going to display static text on the LCD. So displaying static text on the LCD is very simple. All you have to do is select where you want the characters to be displayed on the screen and then send the message to the display. This is what you have to do. So first we are going to do displaying static text on the LCD. So let us write the code. First what we have to do is that we have to include library. So include, inside I am going to give liquid crystal I2C Data library. So this line includes the liquid crystal I2C library, which provides an interface for controlling LCD displays using I2C communication. We are using I2C LCD, not a normal LCD. So liquid crystal I2C dot dash. The next line we have to mention slave address and columns and rows. So liquid crystal I2C LCD. Inside I am going to pass the arguments as 0 cross 27, comma 16 is our column, comma 2 is our row. So this line creates an instance of the liquid crystal I2C class named LCD. So the constructor takes 3 arguments: the I2C address of the LCD display, which is 0 cross 27, and the number of columns, which is 16, and the number of rows, which is 2. And then we can go for void setup function. So inside LCD dot initialization init. So in this case it initializes the LCD display by calling init method on the LCD object. So now we have to turn on the backlight of the LCD by calling LCD dot backlight function. That's it for void setup. Then coming to void loop. In the loop function, first it sets the cursor position. We have to set where we want to print that line. So we have to set the cursor position for the first column and first row of the LCD display using LCD dot set cursor. Using this function we can set. So first one is column and second one is row. I am going to print my characters in 0th column and 0th row. What I am going to print is that like hello. So how we print? So LCD dot print. So inside I am going to give hello. Again I am going to give a delay of 1 second. After 1 second, what is I have to do is that it has to clear my LCD. So LCD clear. So then again I am going to print another statement in the second row. So same, using LCD set cursor first column, right? So 0th column first row. I am going to print another message like LCD dot print Inside I am going to pass this is pantech. So again the same procedure I am going to give delay. First let us give delay 1 second. After 1 second again I am going to clear my display. So this loop continues indefinitely, displaying the hello message for 1 second, followed by this is pantech message for 1 second, and then clearing the display before repeating the process. So let me verify it first. Before that, check your select the correct board and port. Yeah. Now let me verify it. So let me open the hardware also. Let us wait for a few seconds to upload it. Yeah, it is error free. Now let's upload this code to our microcontroller. Wait for a few minutes, the attendance link will be provided. Few minutes, wait for a few minutes. So then again that LCD columns. So this line So this function scroll text takes 4 parameters. One is row, the row where the scrolling message will be displayed, and message, the message to be scrolled, and delay time, the delay between scrolling steps, and LCD columns, the number of columns of the display. So before that, instead of giving directly 16 cross 2, let us make here integer LCD columns, which is equal to 16, and again integer LCD rows, which is 2. So instead of this, I am going to copy this and paste it here. copy this and paste it here instead of 2. So now inside this function I am going to create a for loop. So integer I which is equal to 0 and I lesser than LCD columns, and I am going to increment this. So inside message equal to plus message, and outside this also I am going to give message which is equal to message plus this one. So inside the function, the first adjust the message string to ensure it has enough padding on the left and right sides to cover the entire display width. So it adds spaces to the beginning of the message string until its length is equal to LCD columns. Then it appends a space to end of the message string. For the space purpose, we are creating this for loop. And after this, again another for loop. Inside I am going to give int POS, position, which is equal to, I am going to assign 0 and position is lesser than message dot length, and I am going to increment that position. So inside this line, so next it enters a loop that iterates over each position in the message string. So inside I am going to set first set cursor 0, row. Then I am going to LCD print message dot sub string. So inside I am going to give position, position plus LCD columns. So then I am going to give a delay of delay time. So at each position it sets the LCD cursor to the specified row and column 0 and prints a substring of the message string that starts from position and spans LCD columns character. So this creates the scrolling effect on the LCD display. After printing the substring, it waits for delay time or milliseconds. So now coming to void setup, the same thing, we have to initialize LCD and backlight. And if you are coming to void loop, first I am going to set the cursor at 0th column, 0th position. Instead of printing this message, I am going to change this to message static. So after this, instead of this line, I am going to delete this, and I am going to give scroll text. Inside I am going to give 1, message to scroll, 250, LCD columns. So this line calls the scroll text function to display the scrolling message. It passes the parameter 1, the row number where the scrolling messages will be displayed, and message to scroll, the scrolling message string, and 250 which is the delay time between scrolling steps, and the LCD column, the number of columns of the LCD display. This function takes care of scrolling the message on the LCD display. So now let us directly upload this code to our microcontroller. If it has any error, it will show in the middle of the compiling. So So if I were to tell you something, one is that tomorrow there is no live. You can directly join the class on Monday. Tomorrow there is no live. So next class will be on Monday. Yeah, it's error free and it is uploading. Okay, so now you can see the output here, right? So in first row it will show like static message, and you can see here or not. So in the second line the message is scrolling. I think it is scrolling, right? So this is our output. So this is about scrolling text. Next one is displaying custom characters. So in a 16x2 LCD there are 32 blocks where you can display characters. So each block is made out of 5x8 tiny pixels. I will show you a photo picture of here. So this. So 16x2 LCD there are 32 blocks where you can display characters. Each block is made out of 5x8. 8 rows and 5 columns, tiny pixels. You can display custom characters by defining the state of each tiny pixel. For that you can create a byte variable to hold the state of pixel. So 0, if 1 means it is selected and 0 means it is not selected. Just by giving up in your code, just by custom it using like this, you can get your customized output from there. So let us write the code. Sorry. So the same thing. Liquid crystal, I have to add this, and this is if you are interfacing I2C LCD, these 4 signs are important for everything, and we can delete this too, this lines, and it doesn't need any more this function, right? So until void setup you can delete this, and inside void setup we need to give everything, will come lost, and before void setup function we need to create that byte of, we are creating here a heart. Inside I am going to give 8 rows, right? So 8 which is equal to, inside first I am going to give 0b. So first I am going to give 5 zeros, 5 columns, right? So 5 zeros, comma, same thing, 0b, 01, 010, comma, 0b, third one is 51, and 0b, fourth one is also 5 1, and again 0B 5 1, and again 0B 0 triple 1 0, and again 0B 00 1 00, again 0B 5 zeros. So using these pixels you can customize your own, which you want to be 0 and which is want to be 1. So using this, first I gave 5 zeros. So 5 zeros, totally it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. This is for 8 rows and this number is for 5 columns. So then second row 0 1 0 1 0. So here 0 1 0 1 0, and third row, fourth row, fifth row will be fully 1. So third, fourth, fifth will be 1, and 0 triple 1 0, 0 triple 1 0, 001 00. Here it is 001 00, and at last 5 zeros. So 5 zeros. This is what. So then we can go for void setup. Inside the same thing, LCD initialization, LCD backlight, and then we have to create one more thing, which is LCD dot create character. So inside I am going to give 0 comma our name, which is heart. So additionally it creates a custom character by calling create character method. So on the LCD object, the first argument 0 represents the character number, which is 0 to 7, here 0 to 7, and the second argument heart is the custom character pattern defined earlier. Here we have already initialized this. So this is about void setup. And coming to void loop, first you have to set cursor. So I am going to print the heart in the center. So 6th column 0th row I am going to print that heart, and instead of, we can take this. So instead of LCD print we are going to write. We are going to write inside. I am going to give 0. So it write the custom character represented by the character number 0 to the LCD display using the write method. So this display the custom character at the specified custom position. So let us upload this code to the microcontroller. It is uploading. So here is our output. So if you are changing the columns and row according where you want to print your custom character, in the sense you can print. So this is our output. So that's all about today's session. So is it